Good afternoon, everyone. I hope you're all good. Doing a short stream today. And let me just spam this out. It's set up. We're going to be trying to add a spotlight in the good old filament stuff, which you're probably very familiar with at this point. We'll see how far we get. So we've done a lot on this already. You're probably very familiar. We got as far as the attunement part, but what I want to try and do is implement this at the end. So if we get further, that'd be fantastic. But I think I've said before that weekends are honestly one of the hardest days to stream on because there's a lot of inconsistency. There is an extra thing that I've got to show though, there, which is going to be cool. So let me just get up the chat for you guys. Push over this and get Obsidian, I guess, ready. So we're gonna have to write about this first in our thingy. Scroll down. Okay, and the chat is up. So I don't know how to put this on the screen at the moment, but I'm gonna make a new window, and we're gonna do something a bit different, right? Just for this stream, and you'll see why. New window. And I'm going to go to this website called youtube.com, which you've probably heard of. Going to get 2K, congrats. Yeah, that's exactly... Speaking of, I want to show you this. We're very close to what Raj has just noticed. 2K. Well, look at this number. This is the subscriber count. And if I go to channel analytics and then click on the live count, what I might do is stick this in the bottom corner. So all we need is 2 extra people, so that'd be cool. Right, so what I'm going to do is just for this little stream, let's see if we can get this too. So might be a bit scuffed. So my idea was that we would have like is there a way to fit these together? So while we're studying, at least, we can try, and it's not going to be the easiest to read stuff, but I think it's going to be worth it. So if you just allow me to set up just a touch, and maybe we can squeeze this in. Oh, there we go. Okay, so, we just need to scroll down. Fantastic. That's all I really need to see. So I'm going to squeeze that there. This is a live counter that will be counting as we go, so I can squeeze this much further down. That's fantastic. Oops, wrong thing. Just squeeze this down. Scroll, scroll, scroll. Okay, that's too small. Yeah. Oh! Would you look at that? Dude, we did it. Like, I don't know who subscribed. Honestly, thank you guys. I was expecting this to take a bit longer. Yo, we did it, dude. Thank you guys. I wanted to do it on while I was setting up as well. Didn't quite me like, oh, thank you, Raj. Honestly, that's there we go. So we got to 2K. That helped, honestly. Thank you. So there we go. I'll make a community note on this. Even if this is the peak, even if we get no higher, the fact that we got to 2K, I just to put this out there, my goal, my YouTube goal, was to get to 2K by the end of the year, and we did it much earlier than that. So that's all, and that's all you guys. So honestly, appreciate that. I'll write a more coherent what is it called thought on this, and I'll explain this. But generally, I'm generally very grateful for this. Getting to 2K is such a grateful thing, considering that I was shocked that we had 40 subscribers, and the fact that we're here is awesome. I know it's you know, it's not like the biggest subscriber count of all time, but honestly, I don't care, you know. So I think I will still stick this at the bottom. So whoever, thank you, Raj, and for filling this up, and thank you anyone. Thank you for my first subscriber and my newest, which was just been subscribed. So I think I will just leave it here, just to kind of like as a bit of a momentous. But there we go. We'll try and do that. Okay, that's gonna work. That's gonna work. So that's the current subscriber. Even if it goes down, Yeah, exactly. 2K who are following. That's a really big deal. I just think like 2,000 people who are interested in what you're doing is like really, really nice. And like I said, this was a goal at the end of the year. I didn't expect to get it today. So honestly, even like I said, even if people unsubscribe and everything, you know, hypothetically the YouTube channel blows up for some reason, you know, we did it. You know, we got here. And again, that's all thanks to you guys. So I'll leave this at the bottom. We'll try and implement the spotlight today, so we'll have hopefully something to do, something to display by the end of the stream. But yes, this was a short stream, motivated by the fact that I was so close, and I was like, I've got to do it, dude. I've got to do it. So yeah, I'll leave that there so we can celebrate that as we go. So just because of that, we're gonna if I actually grab my window, can I do this? Yes, do that, and then do this. Okay, so that's easier to read at least. So yeah, I'm gonna leave that there. Hell yeah, guys. All right. So what are we actually doing today? So we got as far as yesterday, with our, I don't know how long it was, 8-hour stream, some 7.5, I can't remember. We got as far as the achievement. Sorry, we got as far as working out the derived values for spotlights, right? The code doesn't look, the maths doesn't look too bad, but I don't exactly know how to convert outer and inner lambdas with this lambda function here, with these cosines. So outer and inner cosines with the lambda. So what we're going to be trying to do today is, yeah, we're just going to go through this, and hopefully this explains how to multiply everything together. And I'll show you where we're up to on the game engine, so if people are wondering, like, okay, what does that mean, right? I will have to re-click everything, but I think it should be okay. Okay, for some reason it's oh, okay, because I updated Visual Studios. Yeah, every time you do that, sometimes you get a Windows SDK and you need to compile it against the biggest things. So, yeah, I'll show you where we're up to on the lighting front when it comes to our little space game that we're working on. And then we'll continue and try our best to implement it. The slowest compilation is actually the physics engine. That's not my code, but you know, it is what it is. And then I'll talk about what's going on. The reason I'm compiling the physics engine code is so I have one less dependency on Linux, so it's easier to deal with the executable. But yeah, it's we basically I fixed the directional light. And for those who weren't here yesterday, this will be kind of cool. And yeah, let me know if the music's all good for you guys as well. If it's too dark, too loud, I'll put this about there. Hopefully that's good. One of my favorite song plays. Yep. Okay. Come on, compilation. I actually removed some of the physics engine code because it was taking so long to compile. So we actually don't have some of the things in the physics engine that you typically do with JOLs. But it was stuff that I was never going to use. It was like, what was it? It was a lot of it was to do with the debug renderer that I'm not going to use, and it was to do with like supporting all different types of APIs. So I think that was a big one when I kind of ripped out. We are running in single thread mode. All right, let's leave that in the background. That'll pop up in front of everything. Let's just do that. So we got our 2K right there. Fantastic. All right, so let's leave that in there. You can see this progression, and instead of just like talking, let's do something, right? And I'll put this on randomized because this is not randomized. I don't mind it not being randomized, but I don't want to be stuck on one thing. Anyway, so yeah, this is the right. So bring up filament. Okay, so I am going to read this out loud as I usually do when I study. And yeah, feel free to ask questions about anything I'm doing in particular, what I'm doing, for people who've made... Oh, here we go. This is the engine. Okay, so, oh, I've got the spotlight. Okay, so now what I'm going to demonstrate here is one, the metalness of this duck actually is almost correct. It's not quite correct. We get some angles that are slightly wrong here, but this kind of looks like a metal surface. We, for some reason, get the colors washed out when we get further around the corner. The other thing that we worked on, which I can show you, is the fact that the lights actually light things up in the right direction. This is the old BRDF, so let's get up the new BRDF, which will take no time at all. All I need to do is type new in, and that won't take any. That'll take like a tiny compilation time, which will honestly be almost instant. Here we go. So this is where we're up to on our new BRDF with a big directional light. So if I turn off this, I have turned everything green. I don't think we'll ever have this color, but we have a big directional light. All the things are lit in the right direction. And it turns out my normal matrix was actually incorrect. And after some help off stream, we found out, well, someone showed me anyway, how to get the normals in an adjunct matrix, which means that we've got a lot better, a better way of getting the normal matrix, which is way faster than doing the inverse. So this is where we're up to, right? We've got like everything lit, and the next I would like to have is wow, oops. Yeah, hi audio, or audio lel. Yeah, so the next thing we would like to add is a nice little spotlight. Because, you know, if we look in this direction, it's kind of dark. And I think it would be nice to obviously simulate this type of directional light with some kind of light source from this direction. And then when you turn around, it's all like lit, which makes sense. I mean, you can. I'm kind of faking it with this light over here, but as soon as you move to the side, it isn't quite. I don't know. I don't exactly know. This is just a coincidence, I think. This thing here, this light. This is just part of the skybox, but it does look kind of cool. I mean, obviously green is not going to be the color we use. Something to match the background, perhaps. But yeah, it's we're getting there. Spotlight in space, yeah, something like that. Yeah, so but now we're slowly progressing through. I feel like as well a good thing that happened yesterday was the lighting understanding. Oh, look at that, 2K 2001. Thank you whoever subscribed again. Yes, okay, so there we are. We're slowly growing. Fantastic, guys. Okay, so yes, I'm going to read through this. I'm going to try as fast as we can to get through because I don't have as much time today as usually do. So this will be a shorter stream, but like I said, I just wanted to give it a little push over the edge, and here we are. Okay, so attenuation function, a proper evaluation of the. So yeah, oh, I didn't finish my thought. Hello, Mabdo. I didn't finish my thought on lighting. I actually. Doing this study really helped me kind of connect the dots with the offline renderer code that we did, stuff that we were studying, and this stuff. Look at that, 2002. So it's really cool. This stuff. This algorithm, or this equation here, made everything kind of make sense, right? We have the BRDF, the thing I've been talking about in this stream. We have the a light emission function, which is, you know, approximated based on, you know, rays and stuff, and the direction at which that's facing. So I wonder why you've never tried to live stream on Twitch. I don't know, actually. It's just I kind of like when I watch streamers, I watch them on YouTube. That's personally why. But a lot of the streamers do dual what is it called? Dual streaming, which I'm completely aware about. So I might do that in the future. I don't know. I'm not sure how many people would watch on Twitch, but yeah, I started on YouTube because I typically use YouTube more. But you might be right. That might be something that we end up doing. Cool. Right. Let's read this out loud and see how fast we can get a. What is it called? A spotlight and start to make this scene kind of really pop and with gameplay and stuff. So attenuation, a proper evaluation of the inverse square attenuation factor is mandatory for physically based punctual lights. So these are just basically for our case and purposes. These are spotlights, which are what we're trying to do, and point lights, which is just a point at which the light radiates from. So the simple mathematical formula is unfortunately impractical for the implementation purposes. The division by so we can't use that. So these are my notes. If people are tuning in for the first time, I'm gonna write notes and then I'll start doing the coding in the actual engine. So that's how I usually go with this at the moment anyway. So I need to get better at like understanding how lighting works. I love that. 2002. What a good day. So we can't use the standard mathematical equation. This is on, fortunately, thank you guys, honestly, for pushing me over the edge just even before I set up. Honestly, it's really cool. But I'll leave that there just to gaze at our success. For implementation purposes. Implementation purposes. Okay, so yes, we have ducks in space. Oh, without a doubt, yes. So the division by the square distance can be okay. So the distance of the the distance. Sorry, the division by the square distance can lead to divides by 0. Okay, so we got to be careful of that. When an object touches, when an object touches the light source, okay, so that's not going to be good. Especially if it's a spotlight, because that's going to happen. Yeah, mostly, a lot of them. Sorry, yep, a lot of programmers watch Twitch. Interesting. The real problem is I'm seeking a new job in Digital Twin and Unreal Engine, and I'm sending the recruiter my progress on the honestly, I have a good feeling that's going to actually help. I'm not going to lie. Having some fundamental understanding about how the basics work when it comes to rendering work is a big deal when it comes to. So, for example, let's just say you get a job at Digital Twin, like you're going to be the reliable guy when it comes to working with shaders, for example. Or maybe because you now know how to handle textures properly, like you now have a better understanding of like how not to make the Unreal Engine really slow when it comes to textures, you know. So it is a good thing. A lot of university students also implement exactly what you've implemented, Abdo. So and they're not necessarily even trying to be engine devs. Just watching. Congrats on the 2K. Thank you. I very much appreciate it. I appreciate you all, honestly. Getting me to that point. It's basically, well, obviously it's all you know. It's not me really. It's you guys deciding to support this endeavor. So you know, I very much it's all on you. So congrats to you guys, I guess. But we'll leave that there as a little celebrational moment while you stream. Anyway, the influence. sphere of each light is infinite. Okay. We'll reach 2026. That'd be cool. Will be the year and the subscriber count. Yeah. Yeah, you're right. You are right about maybe I'll look into Twitch streaming, dual streaming. Actually, just don't know how to do it. More than a lot of the reason why I started streaming is actually a quote that I read from the Higakure book, which is The Way of the Samurai. It seems odd, but you know, it was about doing things that are. The general guise was doing things that are make common sense, like I don't know, you know, having work-life balance and stuff like that. It basically says don't achieve great things, and I was like, you know what, I'm just gonna do something a bit nuts and just stream and see what happens. And you know, I'm super glad. Oh, thanks for just watching. Appreciate that, dude. Honestly, that's really nice and really nice of you. That's really nice. Thank you for the little donation. So that's why I started it. It was not to, you know, to be famous or anything. Yeah, I appreciate that, dude. I put a heart in. It won't let me add a heart for some reason, but so I'll type it in myself. So it's one of those things where, you know, I just decided to do it. Yeah, it's honestly been one of the best decisions I've made recently because of how much help and how nice everyone has been. It's been wonderful. And how much more work that I've been able to achieve because I push myself to make sure that I'm doing stuff for you guys, and I want you to you know, have a good time. So I want to make progress in the game engine as fast as possible. So this like pressure, which I think is good, is pushing me to be a better programmer. So it's all around like a really positive experience. Despite the fact that when I started, I was expecting for some reason a load of haters. It's actually been the complete opposite, which is really nice. With a couple of hiccups, inevitably, but outside of that, it's been, you know, it's been wonderful. So you know, thank you guys for everything. So to evaluate. At the very least, I think I made more progress on the game than I would have than I would have in the world without streaming. So that's a W. The influence of each light is infinite. The isotropic, yes. Okay, so we have an asymptotic. That's the one. Which is 0, which is correctly shape. Which to correctly shade the pixel, we need to evaluate the light. You write every light in the world. Okay, so you have pushed me with your streams many times. I wanted to slack, but after your streams, I get up and finish something on my own engine. Oh, I'm super glad that it's a positive force for you as well. Because I you know, I think I've said this before. Like, my ideal dream situation is one, being successful, working really hard, but everyone who wants to succeed in the chat, for example, I want you guys to actually be more successful than me. So while also me being successful at the same time, because that would be like super cool. So whenever I hear about you guys doing well, it's, you know, it's a massive boost for me. So it's always good that these streams are positive for you guys as well, on the programming front. In the world where AI and, you know, everyone's doom and gloom about programming, the fact that I can be, you know, a positive force for you guys is honestly really cool. So yeah, thanks for sharing that. And that's again another reason why I stream. So it's I'm glad you guys are crushing it out there in the real world. Oh, in the real world, in the wherever you are. With your software engineering. Anyway, so the first issue can be caused easily by setting the assumption. Let's read this. Okay, so the first issue can be solved easily by setting the assumption that punctual lights are not truly punctual, but instead a small area light. I see. Okay, so to do this, we can simply treat punctual lights as a sphere of radius 1. I see. Okay, so we want hit. Hi, Dimitri. Yeah, how is it? Yeah, really good. I passed my year-long goal 6 months early of getting 2,000 subscribers. And we're just kind of celebrating, trying to make a point at the same time. So yeah, it's a really good day today. Yeah, it's yeah, he is right. Enrico Fermi, Albert Einstein, and Oppenheimer achieved more together than solo. Yeah. Yeah, that's the thing. If we all grow together and get better together, then it's a great thing. And that's I'm glad we can do that. So yeah, this will be like I said, not the longest stream because I have it's tough to stream on the weekends. Hey, Matt, how you doing, dude? Yesterday I checked out a stream of programmers, and it was so stuffy. Ah, that's unfortunate. Well, that hopefully isn't the case here. Right. So yeah, everyone's welcome to have fun. Everyone's goal on this stream is to have fun, as long as they follow the rules and do that in any way you see fit. I'm great. Trying to figure out asset metadata stuff. Oh, cool. Sounds interesting. I assume that's to say to speed up some optimization kind of thing, or maybe loading in stuff on the fly, something like that. It sounds really fun. Or difficult. Maybe not fun. I don't know how you feel about it. Like, oh my god, just stop programming the pre-process. Oh, I see. Right. Right. Okay. So the assumption we can make the assumption that we are. I just want to kill myself. If that explains it. Yeah, I sometimes get it. Yeah, but I guess it's part and parcel of the of being a programmer. Hang in there. You'll get it. You're really smart. Just keep on pushing. You'll be a better programmer by the end of the process. Or at least have less hair after pulling it out. The assumption that we... Okay, so have an area light with a small area of 1 cm. Sometimes difficult is fun, not Vulkan though. Yeah. File insets does not need to be Turing compatible. Yeah, sometimes that is the case. Vulkan is easier than what I'm doing, trust me. Yeah, oof, that is rough. Yeah, you'll get there, man. I have faith. To do this, we treat the punctual light as a sphere of... Okay. So we just write this equation out. Yes, I'm going to take the LaTeX from this. Thank you very much. And we'll copy that out so we don't have to type it out ourselves, which is very convenient for us. Okay, so the E is lumens, I think. That is actually lumens. So that's the luminous factor, I think. Let me just scroll up to my my measurements again. So, and it was illuminance, which is the power that's distributed on a surface, rather than how bright something is. So phi is like how bright it is, but not necessarily how much light is transferred onto a surface. That is different. So that's lux, Lux. All right. So we okay. So we can solve the second issue by introducing an influence radius for each light. Influence radius for each light. There are several advantages. Okay, so for the second issue, we need to introduce an influence radius for each light There are several advantages to this solution. Tools can quickly... So an influence radius. An influence radius. So... Is that for the point light as well? Sorry, for the spotlight? An influence radius. I made one scrolling widget this week. It's not that many, but I don't know. Oh, congratulations on getting something finished. Sometimes, you know, having a scrolling widget might seem small, but you know, it's you actually did something, which is good. You know, I sometimes talk to game developers, and they tell me that they didn't do anything. So the fact that you did something is good. You know, that's yeah. So thanks for sharing. Tools can quickly show artists. Okay. The tools just need to draw a sphere centered at each light. Okay, so this allows us to use the debug sphere. At least it's a virtual and compatible with 7 different sources. Oh, there you go. Fantastic. At the very least, yeah. Okay, so tools can quickly show tools can quickly show artists what parts of the world can be influenced by every light. Yep. To show the influence. I wonder if this is true for Spotlight. I'm kind of confused. Because a sphere around the influence of a spotlight doesn't make sense, right? It's a cone. But anyway, the rendering engine can call lights more aggressively using an extra piece of information. An artist, okay, so we can also, which we're going to use later, also call lights more aggressively. Aggressively. 2002, look at that. Using this extra piece of information. Artists can, okay, so yeah, we can also, in theory, manually tweak the radius of the light. Alright, so that, okay, so the mathematical illuminance of the light show getting attacked by a fly. The mathematical illuminance of a light should smoothly reach 0 at a limit defined by the mathematical radius. It is saying that a virtual sphere is drawn around each light source. Ah, okay, so right, okay, so it's going to be like point lights around the source, not necessarily the effect of where it's actually hitting. So if we have a spotlight, it's just going to be a radius around that spotlight, which will be where it originates from, not how big the influence is. Okay. I think that's right. I think that's what you meant. I could be wrong there, because I don't really, outside of that, I don't really know how a sphere would be drawn around a spotlight. So mathematically, the illuminance of light should smooth with 0 at its limit. Okay. Okay, so let's write that down. Mathematically, the illuminance of a light should smoothly reach 0 at the limit defined by a influence radius. Okay, so limits of the light should smoothly reach 0 at the limits. Okay, so no, that is talking about that's radius influence. So that is, yeah, that is that. Okay, I'm getting it now. Okay, so it is that. It is what I thought it was originally. I see the fourth. It says you can change the radius of the sphere of influence of each light source, so you have more artistic control. Makes sense. I see the fourth degree in the formula in physics. I've only encountered fourth degree in the equations for cooling teapots by radiation. Whoa. There we go. Yeah. I don't exactly know this, but we'll dive into it. What is it actually saying about this? So, Coris 13 proposes to window the inverse square function, okay, in such a way that the majority of the light's influence remains unaffected. Okay, the proposed windowing. Sorry, proposes to. Yeah, okay. So the proposed windowing is described in equation 66, where r is the light's radius of influence. Okay, so okay, so Krish. Shall I link this? I don't know. Let me grab that link. So that would be Chris. Let me 13. Okay, here. Okay, so it's an Unreal Engine 4 thing. I think we put that there, and then no, wrong way around. We have a in this blog or art paper. We put paper in like this, like this. Yes, fantastic. Okay. We propose to window the inverse square function in such a way. Okay, let me read this properly and then kind of reword it. Oops, didn't want to do that. So this is a bit of a confusing sentence, so I'm just going to try and parse it. We take the inverse square function, which is this, I think, right? To do this, we treat a punctual line. Let's sphere. Inverse square. Nope. Okay. In such a way that the majority of the light's influence remain. Okay. And we use a function that allows the light's influence to remain unaffected. Fantastic. There we go. That makes sense to me. The proposed windowing is described. So we have this here with this equation where the radius is r and the lights and the influence even, and the influence. Okay, yeah, I'll just write that out. We'll take this. I think we can just take the LaTeX. Okay, so I think so it's mostly unaffected, remains unaffected, so in a way the majority of the light's unaffected, so not completely unaffected. So it's like I don't know how much percentage is affected, but I assume 80 to 90% is fine. So yes, we have a power of 4, which is interesting. Listing. For example, you can change the intensity of a nebula in your space environment. You can control whether the light from a star shines and makes shadows behind it on an asteroid, for example. Right, okay. That makes sense. We've also, side tangent related to that. Thank you for just watching. I've recently acquired, I've been gifted, GPU Zen 3, which is like an advanced rendering technique book. So I'm really interested in what I think is going to be applicable for us right now is trying to implement the what is it called, particle system that's mentioned in this book, which is apparently really efficient. So that might be really a good way to implement, because I need at some point to implement particles, right? In space, there's a lot of stuff in space, like a lot of little things. I think at some point that'll be a cool thing to do. But we'll see. That might be future. That might be future creep. I've got to be careful not to endlessly make features and never release the game. So we'll see. We'll see. That might be version 2. Who knows? Anyway, listing demonstrates how to implement physically based punctual lights in GLSL. Note that the light intensity can be light intensity used in this piece of code is the luminous intensity I, and in candle, it's a candle units, converted from luminous power CPU side. Okay, the snippet is not optimized, and some computers can offload the CPU, for instance, with the instance of square of light inverse fall off. Okay, let me read that again. For instance, the square of light inverse fall off radius or spot scale angle. Did you set yourself a deadline for when you release something? I think that will help with feature creep. That's probably a good idea. I think someone talked about this. Mabdo, I think, actually talked about this. I think I might secretly set a deadline and just kind of, you know, because this lighting, I originally didn't want to add lighting, but I thought, well, I need to at least have some nice graphics for something. The more control you have, the more efficiently you can use your GPU. So it's a balance between frame rate and the number of objects in your world that interacts with light. Makes sense. Okay. So yeah, we're going to try and implement this. I think that's pretty much what we need to do. And then just kind of work backwards, right? Because I think, actually, I'll type this out, right? And I'll kind of explain it to myself as I go, because I think that's going to be the most beneficial. Because this, we have a lot of code here, and I need to make sure that I understand every single bit of it. Otherwise, so this is the stuff apparently that, okay, so this is the attenuation, which apparently can be done, I think, on the CPU based on what it said earlier. By the way, in my opinion, if you're still working on a space game, you should avoid it and work with Crytek sponsor. It's grounded and you can tackle for spotlights and stuff, for lighting. Is that what you mean? For that, I can actually render that model. I know exactly what you mean. So you're saying like this is going to be more beneficial for that particular scene versus a bunch of asteroids in space. What is feature creep? It's the idea that you set a goal for yourself to make a game, for example, and then you say, oh, wouldn't it be nice to have this? Wouldn't it be nice to have that? Wouldn't it be nice to have this? and you keep adding and adding and adding things over and over again. And what was supposed to be a simple game that you're going to make in a couple of weeks can turn into a game that's going to take a couple of years to make, right? That's because you keep deciding to add this and this, this and that, and this and that over and over again. So that's the idea of feature creep. It's like a game design term more than anything. And if you're ever in a project outside of games, this can happen too. So you have to be careful, even if you're not a game guy. Yeah, for lighting calculations, PBR, etc. I see. That's what I do. No. Watch out for that. Yeah, it's. I think feature creep's inevitable. Yes. We might do that in a minute. Then. I'll have to rejig the whole scene setup because I obviously don't want to render thousands of sponsors over and over again in random orientations. But yes, it's definitely possible. I've definitely rendered it before. It's actually the first thing we did was we did a lot of the beginning. Okay, so, a lot of the beginning streams when I was streaming for like an hour, we're using that sponsor thing. Okay, so this is the distance squared. So this is D. This is the D factor, I think. In so what's the fall off one? Oh jeez, got a gnat flying in my face. Getting accosted by flies today. I don't want to make a big clapping noise and scare you guys. You know, I know some of you put on this as some as as a background task while you code, because I know that's what I do for some streamers. Whether it's after the fact or before, and I don't want to like smash the microphone. Okay, so distance squared. So this is in, what is this for? Where is this from? Okay, well, I'll just type it out bit by bit. I'm not sure which function this is for or what. So light inverse radius. Inverse radius. Interesting. I'm glad it's not A, B, C, D, one letter, right? Pandora shouldn't have opened that box. Yeah, it's tough. There are more scenes though. You have Intel Jungle, some Paris London scene. I don't remember the name. Go to Art Station and find more scenes. Meteorites are not decent objects to check lights. Yeah, that's a good point. Yeah, that's a good point. Let's yeah, it's a good. I haven't actually thought about it, so it's nice to be told this. It's not something I think about very often. Oops. Okay. Like what's a good scene? What's a bad scene? Basically, I've never actually thought about it. Wait, people code manually these days. Tell Claude to do it for you. I like coding too much to allow AI to take over. I'm in it for the love of the game more than the outcome of the code itself. So I don't think I'll outsource all my thinking to Claude, which eventually, unfortunately, will eventually fall off when it comes to graphics. It's not as good as it is necessary for like web dev. That's just LLMs in general. And I want to get to the point where my notes and everything takes care of everything that I need. So, okay, so smooth. Effectively, I want to turn my brain into an LLM. I can ask my own brain for knowledge and things like that. Yeah, coding is 100% fun. Yeah. So Matt has said, according to someone, the solution is really that sucks. I always end up writing it myself. Yeah, I've heard graphics and engine dev is not that useful. I don't know why. I guess there was not that much training data, or they just didn't care because they wanted to target web companies, which are the biggest in the world. I don't know. But yeah, I've heard. Yeah, I would rather, like I said earlier, grind it out myself. So okay, so this does a smooth factor. So I believe, what is this function? So we have 3 functions here. Smooth factor divided by the max distance. So okay, so this is, we have to look for distance max, and I think it's this one. Okay, cool. So this is the, I think it's that guy, this guy here. Okay, fantastic. I think that's it. Yeah, 90% of my chats start with me deciding to task the context, then I end up doing the task myself. Yeah, I haven't, to be honest, I haven't heard good things, despite the hype. But also, I just enjoy it too much. So even if, that's just a hypothetical example, where Claude or whatever, like a perfect coding AI bot, completely coded my game engine with one prompt with little effort, right? I just said make game engine, no mistakes, and it actually did it, right? I would still code it myself, because I'm in it, like I'm in it for the love of the game. So despite what people say, like coding is over, when it comes to this guy, which means me, it's not over for me, and I don't think it ever will be. And that's given the most outrageous positive example, right? For shader creation it works, but for architectural stuff, oh my god, it just kills me. I see. I will avoid it. I'll avoid it anyway. Not because I hate it, just because I'd rather do this stuff myself. But yeah, it is funny hearing about it, because I generally just do not use it at all. The most I use it for is I maybe get it to quiz me. Like I get it to write some questions every now and again. Okay, so this is 100% the spotlight. So let's write this comment. So the spotlight angle is human. Okay, fantastic. Cool. I'm excited. Evaluate. No, sorry. The scale. And offset. Computation. And it's funny to talk about this a little bit longer. Tokyo Spliff. I happened to be I caught one of Tokyo Spliff's streams early on. And if you don't know, he's a guy who's doing something similar to I'm doing, but he's way further along with his game engine, and is definitely more popular than I am. I'll say that without any issue at all. Probably he deserves it as well. He's a very good programmer. Anyway, he apparently quit his own job because the AI code kept turning up in his own rendering code, and he just went, you can't write a renderer with AI. And then after he wasn't listened to, he just immediately quit, which is pretty based. I love that. It's just like he was taking none of it at all. He's such a cool dude. Yeah. It's simply impossible for environment with me monofu files. I see. AI is needed for engagement. I don't know what it's called in Russian. Not for me. I love his enthusiasm, but his engine is weirdly structured. I don't know. It's just me. I haven't actually looked into his engine. I love his enthusiasm as well. He's more like for me, it's like his ethos that I love about him. Where it's like, yes, this is the type of like energy that I want to vibe with. You know, don't care, trying to make this cool. Trying to be better, all that kind of stuff. By the way, my engine, by the way, is probably equally scuffed in its own way. So, yeah, I probably can't say much. I know someone in this chat called Ratchet has looked at some of my code and gone, "Whoa, dude, this is a bit scuffed." So I have ways to improve as well when it comes to this kind of stuff as well. Normalize. Hi, Spider Loophole. Man, y'all have Claude AI. Shucks, I can't even have a version of Claude because regional firewall and blocking with heavy filters, and with VPNs it doesn't work. I see. I don't think when it comes to this type of programming, I don't think it matters that much. I think if you just become, like I said, you just become your LLM is built in your brain, for your specific use case. And it seems silly to say that, but some people, it's worth saying. I think honestly, thank you for whoever subscribed. I think you could probably just totally crush it without any help with any AI bot out there. So, Spider Loophole, I believe in you. I believe that you won't even need it if you practice enough. Because if I can do it, I think almost anyone can. When it comes to this kind of stuff. Because I'm definitely not a talented. Like, this did not come naturally to me, all this kind of stuff, and it still doesn't. So you can do it. I believe in you. I don't remember what I ate yesterday. How will I make my own brain an LLM? Exactly. I guess you need more training data. You need to eat more. Yeah, it's a funny thing I heard online. It's like I'm gonna cheat on an exam by this is what someone said, by remembering all the information, and then I'll have an LLM in my head in the exam. So I was like, oh yeah, that's kind of a funny way of looking at it. So that's where I kind of got it from. It was something like that anyway. It's a while ago since I've saw that. I just like that idea. Yeah, I'm gonna cheat on an exam by memorizing all the information, aka studying. Yeah, so yes, don't you guys cheat. Wing the exam. No, obviously, that's obviously a good thing to do. Memorize all the information that you need. Okay, so we're NOL. So this is the evaluation of the function light. I think this is the final. Okay, so this is the final thing. This is the main function. So I'm gonna write like main in your engine main function, right? Okay. Hermes and APIs don't work, and also my PC cannot have big LLMs, even if I have one. Praise my CPU. I see. Well, when it comes to graphics programming, like I said, I don't think you're missing out on anything particularly good. I think it maybe will help you out at the beginning, but you want to build those skills up without an LLM, so when you get to more advanced stuff where the AI falls off and it stops being useful, you have the skills, right? You don't want to be the guy who's AI'd himself into a position where he can't get any better because he doesn't know any of the basics because he doesn't understand anything he's done. So, yeah, you generally... okay, so this is the light position. So we might end up rendering spots depending on how much time I have left. Like I said, it's going to be a smaller stream. Again, which we haven't done in a while. Yeah, if you look back at my old live streams, you can see, well, older live streams, it's not too old. You can see that I use sponsor pretty much in every single thumbnail. Now I've got the space scene as the thumbnail. Alright, so as Metal Squad plays, let's get into this final bit. So tunuation. Get square. Okay, so it's this function, and so I think I'm going to write notes based on how I work this out, right? Pos to light. The engine currently only supports one light at a time, and that's something I'm going to work on as I work through this filament thing. LLMs handle code bases complexity very poorly. I see. Interesting. So yeah, if you've got a complex code base, I guess that's going to be an issue. Cool. I actually like how I approach. I just open up Cloud, and it can see my code base. And in the meantime, instead of asking for code myself, I do a brainstorm, See what the possibilities to review my code. Ah, that's a good way of doing it. Yeah, good little planner bot. Sometimes I forget some C++ rules, and it shows me how to correct those. Oh yeah, okay, yeah. I'm sure there's great ways of using AI. I just even in that case, I'm a bit of a I would rather make the mistakes, plan myself, that kind of thing. I was talking to someone who talks about the game design to an AI bot, and even in that case, for me personally, I would prefer to do all that myself. Just you know, despite my shoddy, well, I don't know, it's not too bad, but my my unfinished architecture in my engine is not ideal, but I'd rather end up with a bad. Okay, so I'm just gonna write this, gonna copy this in, not because I'm too lazy, because I'm probably not gonna use it, because this okay, so yeah, we've already kind of done this. So I need to write my version basically over that, because that's what I want to do. Because I do it like this when it comes to... Okay, so that's the lumens, so I'm going to get my lumens in. Which is... Let's just make sure this is 1-to-1. And so we have light color, we have light intensity, the direction, and the extra thing we need is a attenuation, which is done before the direction. So back here. Fantastic. Okay, so that's the actual big deal that we're trying to figure out here. And the BRDF is this, the light intensity is this, the attenuation is there. Then we have L.L, and then we have the color. Alright, cool. So that's what we're going to do. And yeah, we're going to throw this into our shader and try and get this to work. This is the battle of the stream, right? Trying to get this to work. I'm going to build an app with Python that plays Red Sun. I'm not sure what that is. If it detects the user is from China, from his search history, C++ is a low-level language. China doesn't like low-level. Interesting. Oh, I see. It plays like a song if you're Chinese, or in China at least, or Chinese from your search history. That sounds like an interesting project, to say the least. Okay, so let's throw this in here and see what we're missing. It's a song. Got you. Yes, I'm unfamiliar, but I think I get it. All right, so let's compile and see how this breaks. Okay, so we have distance. So I'm sure there's something that's not right here. Okay, so we're missing a... Oh, yes, we don't want to do this. I want to do this in my own code, so I'm going to actually pull this out. That's why this is kind of broken. I throw this at the bottom. And we're not going to use the directional light just briefly, because we actually want to see this light instead. Light to weld position. That for us is big L. So we are going to use... Do we even use these guys? These N.H... Yes, okay, so we N.H... Do we use this at all? I feel like we're missing some of the things that we just don't use. Okay. Yeah, it sounds like a funny app. I'm going to troll my friend from China. Fair enough. Yeah, it sounds like a good prank to pull on your mate. Okay, so we want... Okay, so we don't need this, really. I don't think, anyway, because we have the world position way up here. So let's see. You know what I could do, because I feel like we're going to be in this for a longer time. Just, again... Just more of a thank you than anything. We'll throw that there, and I'll make it much smaller, obviously. But what I'll do is kind of like brush it off to the side, like that. Maybe even make it a bit wider, kind of like that, right? So it's still there, right? While we're coding, kind of cool. While that's there, while we're coding our shaders, I might squish this a little bit so we got more coding space. I think that generally doesn't make any difference now. Okay. Right. Okay, so we got a... okay, so this is our L, which if I look at the light to position, I believe... Yeah, okay, so this is the kind of confusing part. It gets the light normal first, and then it does the subtraction. Why? How do you know this is not... I have a feeling that this makes more sense in our case. Not because it's correct, but if we look at this, right, that's the eye of the camera, and that's the position. And... oh, it's the V. Ugh, what am I doing? I need the actual line, not the V. That's the what we're looking at. Sorry, wrong thing. I was a bit confused, and I was like, what? How are we going to be lining this up? If we're using our eye is the thing. Oh, this soundtrack is so underrated. Okay, so... hey, bro, what are you, building? Yeah, I can show you. We're building a little space game. I'll just comment this out so it doesn't complain. If it... well, it might complain it's something else. Let me comment this out. I'll just show you real quick. Because we're currently in the middle of trying to get this to work. Yeah, so it's this 3D game engine. And... if I turn off the debug geometry, I'm currently working on the lighting to make the lighting better. Everything will be green. I've just kind of set that up as kind of like a fun color to contrast the background with. But we have these ducks, which will be other things in the scene, and I'm trying to work on getting this kind of like nice and playable, getting the light to look nice, so everyone can have a go. All right, I'm gonna go. I'm gonna come back and build my generator. Yeah, good luck, man. Yeah, so that's what we're trying to do at the moment. At the moment, oops, there's a bit of an error right there, but that's a work in progress. It's not going to be a massive game. It's going to be a little arcadey thing. But yes, we're currently working on getting a spotlight into the scene, which is, you know, something that comes out of a torch. Or if you're an American, it's called a flashlight. Yeah. So we want that kind of effect. We call it a torch, even though it's confusing for Americans because they have another. We have two words for torch. But anyway, one being the one with a flame on a stick, and one being the what is it? Flashlight, right? Trying to remember it. Okay, so we have n.l and let's just see what we're missing, right? So we're getting errors down here. We're trying to fix them bit by bit. So outer angle is undefined. I think outer angle, not out angle. Just probably a typo there. Oh no, interesting. Let's look at the... what did I type in here? Oh, it is outer angle. Yeah, out angle. That's my mistake. So outer angle gets built again. So it's just I'm gonna clean up our code. One error at a time. L is redefined, which is much further on, which is great. So yeah, I'm gonna kind of bring everything together. So I don't mind commenting it out for now. Right. Okay. So that's everything we need. If I build again, we have oh, L is defined twice, really. So vec3. Okay, so capital L is defined twice. I'm gonna say light, maybe. That's gonna fix us for this. In this case, it doesn't really matter. So that's the n.l. Light position is so build. No, L is redefined. Okay, so there's a capital L somewhere. Where? It's in the fragment shader. Oh, I can just look at the line code, obviously. 250. 200. Oh, it's undefined now. Okay. Right, okay. Okay. Duh. Obviously. I thought it was redefined. So the next error is n is undefined. Where is n? Oh yeah, I think I use a capital N when we're doing this, which is easy enough to fix. We have n.l, which is probably already defined. Yep. Okay, so dot. I'm also going to get rid of this. Okay, so let's comment this out. We still need the BRDF, so we need everything up to here. I don't think we need anything else, so let's comment this out. I'm going to take this equals this. Okay. And get rid of this return, because that's not anything to do with anything. So we have n.l. Change that to that. Okay, so we have this function, we have position to light, we have light in radius. Light in... Let's do a... I assume this is just a float. I don't know what this is going to be. I assume this has come from the... What is it called? The CPU side. So let's do a safe 5. I don't know what that's going to look like, but at least we have that defined now. Inner and outer angle of lighting direction. Alright, so let's build and see what we're missing. Light position, yes. Which is this. I assume that this is similar to the directional light. Maybe. Light position. I think I can probably just reuse my lighting position that I get from inside the CPU, right? Where is that? Okay, so light position, which I assume. Okay, so that's the light. Right, sorry, what are we looking for again? Light position. I'm gonna go with the position minus world. Let me look at this again. Alright, so I'm going to scroll down here and throw it. I have a feeling that we don't need to see this at all. Light position is what I've already typed in. Right? Yeah. Yeah, okay, so, yeah. Right, let's fix this. Normalized light. Yes. And this is light position. Okay. Do this, and normalized light is there now. Okay, cool. World position. Again, when it works out, let's go back to filament briefly. Let's get rid of this. Let's pull this over here. Its light position is overwriting the light position. Oops. Sorry, let me light position. Let's comment, paste this in so I can just refer to it. Obviously it's going to be commented out, but delete. It's going to write that there so I don't think it's anything useful. Light normalize. fantastic. Let me just check something real quick. On my end, it won't take too long. Yeah, I just need to look up something on another computer. Cool. Yeah. Okay. Everything's sorted. Okay. Let's continue. Right. So we have light position. Yeah, I had a feeling this would be like awkward to work out. So okay. So we have n.l clamp to 1, which is this. We have light position and whirl position, but it's light position. I have a sneaking suspicion that this is our case, right? Put that there. We normalize the given light, and then this all kind of works out. That's as far as I can tell. Okay, so attenuation. We have the inverse, right? So I'm just going to set like values. Okay, so we already did that. We have L, which is, what is L? So that is not light position. This is just light now, and that also breaks. Okay, so we don't have light position. So get rid of L for this, and light direction. I think we can set this ourselves. This is fine. Light dir. The inner and outer angles, I have no clue. So these are, I assume, between 1 and 0 and pi. So yeah, all these three I think just have to be defined for our particular use case of an angle. Sorry, of a point light. And this is why we might not, this is why the scene might not be lit very well. Because this might be really small. So float. And float. Okay, so light direction. It's going to be very straightforward. It's going to be vec 3, 0, 0.0, oops, 0.0. Inner angle. This would be smaller than the outer angle, so let's look at the filament again. But I'm going to look further up, right? So it has, I think, so inner and outer. Does it have an example? Okay, so the ranges from the left are outer angle of 55. So I think we've got the best shot with a 55 degree. And I need that to be, I believe, in radians. I don't know 55 degrees in radians. So I do know that 45 degrees is half of 90, which is 2 over pi. So I think we can go 4 over pi for outer. Is that right? So 4 over, so that should be roughly a little bit brighter than this. So 4 over pi. Because pi is, no wait, that's, pi is 180. 1 over pi, wrong way around, pi. Half of pi is 90. And 45 is that, okay, so, oh, that's the inner angle. Yeah, I was right. I'm just thinking of a unit circle right there. The inner angle, I have no clue. So obviously it's going to be less than that, so if I did 8, that would be, I don't know, quarter, whatever half of 45 is, so 22 and a half. That seems too small, so I'm going to go with something like Pi over 6, right? I don't know what that is in radians, but okay, I think we have all the values defined. This might be wrong though, so we might not get any light at all. We might get some weird effect, but we do. I think we are setting out everything correctly as far as I can tell. So let's give this a shot and see. Oh, it doesn't build. Okay, what are we missing? Cannot convert. Oh yes, big mistake right there. Light direction needs to be vec 3. Light intensity is under. Okay, so that's just that was commented out unnecessarily. Okay, so the assignment in 341 of a for what value though? Okay. Surely you should be able to do this. Let me look at the filament code one more time. Okay, so just gotta plug you guys in. Laptop's dying. Maybe did you rate it? Whoops. Knocking over things. Bro, how many years have you been bro, how many did you rate it? I think we just need to figure out what multiplication is not working here. It's one of these, I think. I thought you were able to just like multiply a float together, right? So I started in 2011, so it was a long time ago, but I took lots and lots of breaks. Crispy, from my coding experience. I really started to, from a young age, approximately throughout your life. Yeah, so I really started to like take it seriously later on in life. When I got my like first job, I kept hopping from language to language, not really getting anywhere in any language. So, you know, I had lots of other hobbies at the time, and I feel like I was always starting from scratch when I was learning coding, because I kept giving up on stuff for such a long time and forgetting everything. So I do believe that you don't necessarily need as much coding experience as I do to get where I'm up to, basically. So I wouldn't worry too much about that. Oh, this is a Vec 4. Right? Yes. Oh, I need to decode all this. Right, okay, so this is a bit trickier. So this needs to be assigned to a value. Okay. So Vec 3 luminance. So yeah, it's you could get really good at this like very quickly if you just put in the time. You don't need to be like a grind, like work for 10 years and then you'll finally get good. Like I generally believe like I could have done a lot better if I didn't take so many breaks. So let's throw this in here, and that should be good. But it's hard to know what you want to do when you're younger, right? So there is that. Ah, there we go. Okay, so that fixed everything. So let's see what our scuffed spotlight is doing, if it lights anything at all. So this means it's not lighting anything, but we might have to convert to a different model to see the light, because, or at the very least, let's do a cheap fix for a minute just for this light source. What I'm going to do is reduce all the asteroids and kind of bring them all together. No, that's going to be a bit awkward, because that's going to cause the physics engine to freak out a bit. But let's just see. Let's just do the rubbishist approximation. So we have 2,000. And I'm going to make this like 500, right? So everything's like smaller together. What's this game about? It's like a little space game. It's going to be a pretty arcadey little game. You're going to be flying around, exploring, maybe doing other stuff. I haven't quite decided all the mechanics yet, but I want to at least make it a little pretty. So I'm trying to work on the lighting at the moment. Okay. So we brought all the asteroids in, and as far as I can tell, nothing is lit. I think this is okay. So this the red is the debug geometry, so I can see everything. So right now it looks really dark, but there's supposed to be a spotlight, which is something that comes from a torch or a flashlight, if you know what that is. Depends on the language that you've learned English from. If you, well, yeah, not necessarily, or if you're American, I say torch. Always have. The game is content, but I understand it. It's primarily for programming. Yeah, it's trying to, what my goal is to make the engine, the game engine that we're working with, able to make a game, right? That's the actual primary point of this exercise, more than, trying to make a game. So what I'm thinking about doing is, hopefully it's at least somewhat fun. I do hope that at the very least, I'll try and make it good for everyone. But it won't be like a big thing that'll blow your mind or anything like that. Okay. Right, what am I doing? I'm trying to figure out what language languages do I use? In this case, it's C++. With a combination of Vulkan, which is for the graphics API, but that's pretty much it. I'm not going to add any scripting into this game engine, so that's all we're using right now. A bit of C every now and again, but yeah, it's basically C++ pretty much all the way through. I know it's not the coolest language, and then make a game. Yeah, too. Yeah, I want to make this is going to be a game. But it's gonna demonstrate that the game engine can make a game. Basically, that's the main priority. So let's run this again. I think we're okay with this scene. I don't think it's too bad. I think if I bring back the directional light in, let's bring back the directional light. Let's just see how the likelihood, or I can even reduce it. Maybe I'll bring this down to 300. Let's just make sure it doesn't lag to infinity when that happens, because there's going to be tons of physics happening all at once, because the physics will push each other out from itself. Yeah, there it is. There's a physics engine kind of cooking the CPU. So let's I think it's too small. Basically, if nothing displays almost instantly, we know it's too intense on the CPU. So okay, so more or less that's good. All right, let's just bring back the directional light in. You got a laptop or a PC and specs. Okay, so my specs. There once was a bot that did this, but let's. If this doesn't work, I'll let you know. Does this bot still reply? I might have to. Yes. Okay. There you go. Thank you, Nightbot. They're my specs, and I have a PC. So the only thing that's kind of remotely impressive is I typed G-force wrong. G-force. Nice. Yes. Never mind. I can always fix that later. How many dollars for that GPU? At the time it was cheap. It was just before the AI boom kind of stole all the computer components from the world. And I got it for roughly $550-ish at the time. It was more expensive when I bought it. It might be cheaper now. I actually don't know. Okay, so what I want to do is add the directional light back in. I want to become a game developer, but I have no experience or no knowledge yet. Where do I start? It depends on what you're trying to achieve there, my friend. If you're trying to just make a game, I recommend doing game engine. I recommend using a game engine. So I'm just going to add this back in and just kind of see where we're up to. That was my Windows noise, apologies. But if you're trying to do what I'm doing with engine development, then you're going to have to get really good at, well, not really good, just competent enough at C++ to be able to do graphics programming and stuff like that. Bro, you're lucky. Yeah, it's, okay, that's good. Okay, so as far as I can tell, yeah. Okay, so I've brought back the directional light. This is, I think this is dense enough that, this looks really strange. Dense enough that if things were being lit, we would see them. We would see them in all different angles, no matter what. Okay, so, yeah, I would ask you, what type of games are you trying to make, and two, how do you want to make them? That's the first questions I would ask if you want to be a game dev. Why do I ask that? Well, it depends, because that's going to change your path. There are two paths that are generally advised. There's game engine development, which is what I'm doing. There's a bit, which is a harder path in general, and there's game dev path, I guess, which is using Unity and Unreal, or RPG Maker or whatever, you know. And that depends on the type of game that you want to make. So yeah, okay, so let's run this again. Bro, does your work get hampered by the i7 and the 4070 since you run? No, typically they're quite good. It is older, I do have to admit, the i7. Light intensity needs to be left alone. So I'm going to put this above specular so I don't keep doing that. But yes, I definitely could do with an upgrade, but it's just really expensive to upgrade anything when it comes to computers right now. Especially because my motherboard doesn't support Windows 11. So let's run this again and see where we're up to. No, I don't think we get anything, do we? We just get the base almost darkness light. Right, okay, so let's restart the music. Which is found in here. Right, okay, so I wonder if the radius is too... Let's make the radius like pretty big. Obviously it can't be more than pi, so I'm going to do that and that. We're going to increase the radius to maybe... It's going to increase some of these values. 400, something extreme. What is the void engine thing? That's my old... on all the processors, cache misses are noticeable. That's my game engine that I'm making myself. So this is the game, but it's like I'm trying to get a spotlight to be rendered, but I don't see anything, unfortunately. Okay, let's keep going. Yeah, so I'm very cautious of cache misses. Actually, it's one of the things I've written my game engine around. When a project lags during development, it's a big hint that something is done wrong. Yes, I will investigate all those type of things and drill into them before I release this game prototype thing to the wider world. Okay, so let's get rid of attunement. Let's just see what happens if I do this, right? I think that just gets rid of everything, so... Yeah, okay, so I believe... What do we have here? Right, let's turn off this. Is everything lit uniformly? It's quite interesting that my it gets darker as I get closer to the object. Very strange. Okay. So it looks like my attenuation even is too high, right? Okay, so I have a really terrible profiler, but I'm going to implement Tracy and make sure that works. Wow, you made a game. You made a game engine. Wow, I didn't really know much about programming. I'm a beginner. I know HTML and a little C. Oh, well, anyone's welcome in the stream. And so any questions welcome when it comes to this type of stuff. But yeah, I've been coding for a bit now, so I have a feeling that... I wonder if I can increase this just a little bit, like... I think this is too low. So I'm just going to, like, add an arbitrary value to it, just see, like, how this works. Oh, plus equals. That's going to do nothing. So, oops, that's... oh, I thought it was multiply. But yeah, thank you. Thank you for the compliments. Oh, what? Oh, I didn't. Did I? Hang on. Oh, no, I did. Okay, interesting. Right, let's see how this is being affected by things. So turn this off. Okay, so it's darker this way at least. But it's massively... Okay, so I'm going to like kind of escape the asteroids and just kind of look. Where's the light coming from? So this is not a directional light. Huh. Okay, so let's rearrange the light then. Let's put the light on Y, right? So that's the X direction. This is the Y direction, and kind of see how that affects things. I saw that too, Tracy. I kind of I tried KD hotspots, and it's a good option. You need to run the binary. I see. Okay, so the attunement is, if I just add 1, I think we just get like, let's reduce the radiuses maybe. So we have in and out of 6, and this is 4. Hello, Alex Codes. Thank you for joining us again. For tinkering in Just the Shaders, it's quite nice to hot reload to work. Cannot recommend it. Yes, I don't have hot reload. I kind of got in a bit of a trouble. What's up, man? How you doing, dude? Thank you for joining us. I think it's fast enough right now that it's not too much of an issue. Alright, so I'm going to get rid of this attunement anyway, so... it might be the intensity, hang on. Let's put this back to 5. Oh, sorry, yeah, I've missed a question, Crispy. What can you do, what can I do to see good returns to effort easily if I want to call myself a good programmer? What would be the steps and path? It depends on what you want to make. So, okay, so like if you want to do what I'm doing, there is a bit of a trap though with calling yourself a good programmer. I honestly don't feel like a good programmer sometimes, if not always, you know. So how I feel is not necessarily thank you for who subscribed. Is matching realities. You gotta be aware of that. Outside of that though, if you want to just get better, just be aware that yeah, it takes time. And if you want to get better, I would recommend, if you want to do C++ like I'm doing, go to learncpp.com and see how far you can get through that. So if you literally type in learn, no commas, C and then PP, right? You'll be able to. Thank you for another subscription. I had this goal of trying to hit 2K today, and look at us now. You know, thank you guys. It's very much appreciated. So that's what I would do. If you want to get good at this, you'll have to learn something like C or C++, Zig, Rust. So yes, learn the basics and make sure you're very good in general. So I can probably if you want to do what I'm doing, you want to get to the point where I'm able to quiz you as a junior programmer, in a job interview style. So you need to like know not necessarily like how to do this specific light scene like right now. If I made a tutorial about how to do this, you want to have like a good general base, and that's where I would start, honestly. Yeah. Does it make yes, make a project. Go to thank you for another subscription. Ayo, is this a game engine? It is indeed. Does it make sense? Yes, projects are good once you've got a bit of experience under your belt. Oh, another subscription. Wow. So yeah, make sure you've got a bit of experience and then dive into projects. But don't use AI, because the AI will make the projects easier for you to do while decreasing your skill. And the whole point of doing a project when you're learning is to increase your skill, so you can do things by yourself, I assume. That's your goal. So, you know, if that is your goal, so I don't know which ones, then I would do that. Okay, so let's look at this inner and outer angle, maybe. Okay, I'm going to increase the intensity like crazy, and see, like 5,000, something like that. I subscribed. Bro, give me an RTX 5090. Okay, I'll have to rob a bank to get you that, I think. Excuse me. So maybe after I've done that thing. Yeah, because I've heard they're very expensive. Right. Yes. Yes, it's a game-specific engine. What I would call it, there's two different types of engines out there. There's the capital E engine, Unity and Unreal, right? Like, these are used to make a general product, capital E engine. Mine's a lowercase e engine, which is used to make a specific game, but it will be used to make other games. But it's going to be the game and the game engine will be very tied together. Because if you make a game from scratch, you make a game engine just automatically. And yeah, so I'm going to try and increase this. So it's not like you could download this engine and start coding your own thing. It's very much like what I call, like I said, a little E game engine, right? Okay, so let's change the direction. But I would still personally call this a game engine. The definitions aren't too important. What I'm doing here is just coding things from scratch to simplify it down. So I'm going to use L here and kind of see the difference maybe. It looks like red. It looks like red blood cells, or your. I see. Yeah. Hey, Yip Tag, how you doing, dude? Good to see you, my man. No, still not very good. Okay, this is not good. Okay, I'm gonna have to sort of change my approach because I'm definitely running out of time. To make this spotlight work in the way I want. So, okay, so let's dig into the. Do you have any eye strain management tips? No, pretty much all I do is like look out a window every now and again. That's pretty much it. I don't really have a good management. So I'm gonna bring out my notes and just kind of look through this a bit and try and work backwards. Okay, so these two functions are. I corrected them. There was a couple of mistakes that I had when I originally typed them out in my notes. So let's throw this in here. Okay, assuming that I get everything, then we should be good. Yeah, so, yeah, here's the other thing about game engines, just for people who are wondering. Like, you can make a game engine and a game, and it can actually be easier than using a game engine to make a game. So sometimes it makes sense to actually use a game engine to make your life easier. Like, making a game that's purely text-based, for example. That's hard to do in a game engine. But if you write your own game engine, which should be very simple, then you can make like a really cool, quick game. And that's some of the projects I recommend to people who are new, when they want to do this type of stuff anyway. So, right, let's see. So I'm just going to read some notes based on this tutorial. Well, not tutorial, this documentation of this other engine. Because this is what we're following right now. So I'm going to grab this and kind of throw this at the bottom like we were and just kind of read stuff out and make sure my notes are good because I'm a bit confused. So I'll throw this there and there we go. Bring this across and bring this like this, then bring this up. Okay. I'm just leaving this here because it's kind of fun. Like I said, I wanted to get. My goal with subscriber counts was to get 2,000 by the end of the year, and look at us now. Anyway, enough yap. Let's continue. Have a nice session. Yes, thank you, Matt, for joining. Generally, yes, I try to stream daily. I just can't stream every day. Not every day. So it's like almost every day. I have missed many streams because I've been at school, but I'm wondering, will you implement global illumination? I'm going to implement something close to that. Probably not straight GI. So, okay, this is a bit finicky. Okay, that'll do. Okay, so demonstrate how to implement physically punctual lights in GLSL. Note that the light intensity used in this piece of code is luminous I in candle units, converted from luminous luminous power CPU side. This snippet is not optimized, and some okay, so we need to offload some of this. Yes, for instance, the inverse square light fall off radius or a spotlight. So this goes into photometric light. So we've really got to dig into this, otherwise we have not necessarily succeeded. Does this formula depict? So this formula is supposed to depict a. Let me explain it. See if I can explain it to you. So this one specifically is the illuminance of light, which is how much light energy is distributed onto its surface. And so what we're trying to simulate here is the fall off, I believe. So I think it's this function right here. Yeah, don't worry about the number going down, that's inevitable. The illuminance of light should be smoothly, and so it's got to smoothly reach 0. So and we've got to worry about the inverse square law, which is about how light, based on its radius. So if you imagine a radius around a sphere, hopefully you know what a radius is, but if you don't, that's just the half distance between the middle of a circle or a sphere to its circumference or its edge, right? So from the center to the circumference. And if we have a light and we take that radius of where it affects from its radius outwards, then the inverse square law is 1 over radius squared, and that's how much the light, I guess, degrades over time. And the light degrades over a distance, right? So that would be the distance it degrades over, I think, right? No, sorry, that would be the just pure distance. Sorry, I got that wrong. So it's not the radius. That would be the distance, because the radius is just the influence, and the distance is just how far away from the light it is. And if you're really far away from a light source, then it's 1 over distance, not squared, not 1 over radius squared. It is nice to see physics formulas in games. Are you good at maths? Probably not as good as I should be. So it's spelled light wrong there. So, okay, so we take this inverse square function, which is, I believe, the 1 over distance, and use this function. Oh no, it's this. Okay, so it's this. Okay, so that's the inverse square function, right? Okay, that's good to know. And we have this in with our equation, with where the radius r. Okay, so so this is the inverse square function, right? And we make sure that originally this function didn't have any of this in here. That's for but we need to make sure that we don't get a division by 0 where distance is equal to 0. And I believe 0 to the power of anything is 0, so because 0 times 0 is equal to 0. Everything is maths at the end of the day. Physics, maths, computers, maths, the universe, yes, 100%. Yeah, science, 100%, exactly. Yeah, you really can't live without maths when it comes to the kind of stuff, so yeah, it's so we have these we have to make sure that we can't divide by 0, because in video games that can, well, in computers that can break everything, right? So the second issue is we introduce a small influence radius. Okay, so the influence radius is this 0.1 at the very least. And this max function, if you don't know, just takes the maximum value of each, whatever, once we've squared it. So if D is too small, then we pick this other small value, epsilon, right? 0.01. Epsilon is just a stand-in for a small value. Okay, so this allows us to use the debug sphere for know its influence. Science is just maths in words. Yeah, pretty much. That's a good way of putting it. I like that. We also cull light more aggressively. That's not how you spell that. Aggressively. Using extra piece of information, we also you know, I'm going to look up something and compare it with another tutorial. This is a great resource if anyone's ever used it, but it's only for OpenGL. Well, you can use it for other graphics APIs, but it's going to be useful if you're like me trying to figure out this particular lighting. And I just want to compare it. So this is ambient light, which we don't need. Ambient strength. We have a normal, what is it called? Normal matrix. I don't know what light this is. I think it's just, what light is this? Okay, that's a point light. How do you recover after coding? Usually I just play a bit of video games. The reason I'm, you know, into coding video games is because I really love video games. So that's typically what I do. Light casters, maybe? I actually don't know what... Okay, directional light. Here we go. So directional light we know how to do, which is really easy. Point lights. So... Okay, so it literally... Okay, that's good to know. So hopefully we've got spotlight here. Okay, so do lighting calculations. I'm going to ignore that. Okay, so what we're going to do is just try and get this to work, right? This is just as simple as it can get. Then OpenGL does not use attunement with the inverse square law since it's not really physically based. Ah, thank you. That's actually really good. That's more screen time, buddy. Game over, yeah. I do go to the gym. That's another hobby I have, but I'm not particularly strong though. So I do keep healthy and do other things. I swear I'm not you know, 400 stone or whatever. So ambient. I am just going to implement this though, Ratchet, because I'm trying to figure out just like how to get it basically working in a very rubbish. I just want to compare the results as well. So the ambient light times by, yeah, do lighting calculations. What is the lighting calculations though? I'm just trying to compare the values more than anything. Oh, there they are. Okay, so lighting direction minus direction light cutoff. So I can just set these values, I think. Okay, so I'm going to throw these in because I am running out of time. So hopefully you can... I don't recommend doing this, by the way. So we do have attenuation here, but well, I'm just going to throw this in here and just kind of try and figure this out backwards. So excuse my rubbish. So I'm going to say there's just a small value here, like... Do we even need this, to be honest? So the epsilon is 0.01, and I'm going to get rid of this completely, so it just makes things simpler. The outer cutoff, I believe, is probably the outer angle, and then the direction. Right, okay, so... Lighting direction. This is just this. Normalize minus, dot product, the minus. Okay, so we got theta, and I believe the outer. The cutoff. That would be a vector. I have no idea what that's going to be hard coded. Gosh, this is trying to make a cone. So the first way to do this in log L is a bad way to do it. the first way to do it in... Oh, the first way to do this is do it in Learn OpenGL. It's such a bad way to do it that John Kronos will get you. Okay, admittedly, that's good to know though. I don't know how bad this is, right? But we do have it here. It's just I would just like to have at least the intensity, the attempt to be at least achieved, you know. So light intensity. So we don't have this, and I do believe you though, Ratchet, that this is not ideal. So what would this be? This is just a vector of, I don't know. Let's make it a wide cone. So 10 F 10F 10F 10F. So yeah, believe it. I'm trying to build a physically based renderer. This is not physically based even a bit. I could tell you 2 mistakes you're making here, but it wouldn't be funny. Okay. Yeah, I'm just against the clock. Convert. I would again take more time with this 100%. Is this not? What's theta? Oh, it's a float. Oh, it's clamp. Oh, I'm an idiot. Okay, sorry. All right. Learn CPP, that website. What? That will teach you C++. So nope. All right, I'm gonna have to. What am I gonna do? Okay, that didn't work. Okay, that was just. Maybe that. Yes, I did actually use that site back in the day. I always like I said, I started to learn like properly in C in like 2017. So I went through it like in 2017, which is quite a while ago. I knew it would be funny. Okay, yeah, it's my all right. I do not see this even a bit, so I'm confused, honestly. What is this even doing? This is the intensity? Let's set this to a big value. I'm just kind of curious. Yeah. What does this even do? Okay, so it just lights up everything. That's because we just got an intensity value. Yeah, everything is just green. It is more lit in one place though. I think it's just the general direction. Yeah. All right. That was a fail. Let's not do that. Next Hideo Kojima upcoming. Yeah. Green mode activate. Shrek the space game or something. I don't know. Okay. So so let's go for the maths again. So this is the effect, obviously, I'm trying to make. But I thought I could just plow through the theory and get something on the screen. So the equation, you decrease the... Yes. Okay, so that's just the integral. So phi, which is the power, over 2 pi minus cosine divided by... is the illuminance. equation power. Yeah, and so then we just do that 1 over pi with a light absorb. Here's the thing I don't quite understand. What with a light reflector? What is this versus this? Is this the physically accurate one? I don't know. Do you prefer learning with videos of a tutor or reading websites? I just go with whatever's available, to be honest. At this point, websites are better because there's just less stuff out there in videos. But I still use videos. I still watch videos to learn the stuff. Ace Roller has a great video on physically based rendering. When he talks about like how Disney lighting is very similar to what everyone else is using. It's actually really well put together. For example, that's a really good video for this type of stuff. So the spot direction. So L dot spot direction cosine. I prefer text over videos 1000%. Yeah. You're actually like pretty sharp on the resources that you go through. There, actually, it's pretty admirable, all the resources that you provide. So okay, so at the very least, let's make sure this is correct. So when I'm doing this lambda function, which needs to be multiplied by this guy with the light reflector, I guess. Let's at least make sure this is correct in my code, and then we'll at least be on the right path. Which function would that be? That would be so that's the distance function that we worked out, and this is the inner and outer angle, right? So this is this function, which is the lambda function, which we need to multiply by everything. So okay, so this is in candles. Okay, so light direction, which we send in. I wish I could copy and paste LaTeX without it making sense. Yep, Ratchet's 100% correct there, Crispy. Just if you're trying to make a project. Like I said, I know it's a bit of a broken record here, but even if you're struggling, don't use AI. Because you want to use it as a learning experience, in my opinion, right? I mean, you can do what you want, obviously, but if you want to improve, that's what I would do. Okay, so L dot spot direction minus outer angle. So where's that? Okay, what is this doing? Okay, so the lambda is in the equation. I have a feeling that that's not what we're working out at all. So spot scale, inner angle. What maths equation have we picked out here? I'm so confused. What would you suggest? I'm in a loop of watching tutorials of arrays of pointers. It depends on, like I said, you need to work out what you want to do, and then you can pick a tutorial that makes sense based on what you want to learn. So if I just say learn this tutorial or whatever, or do this project, I don't know what you want to do. I'm pretty sure the code version is optimized to use multi-ads. In my code, mine's pretty easy to read. Lol. Yeah, that's the problem. I can't really translate this function, which works out the luminous intensity. I think it's the intensity. Hang on, what is it? Yeah, luminous intensity. Okay, so okay, so this is important. If we look at the luminous intensity, which is, I think it's what's turning up here is, we have candle units here, which is L, which is the light, normalized, dot the direction, which just gives us the candle, which is, or candela, sorry. Candela. That gives us the candela unit. And then we clamp that at tune. Spot scale. So you can see a lot of optimizations like this. I see. So this is a lot of optimized stuff. The problem is it just doesn't work for me, but I don't really have all the data to pass in. I think what I need to be able to do is at least maybe have it so I can press numbers and increase and decrease these values, because right now I don't quite know what I should be seeing. Yeah, it would be nice to see yours, Ratchet, if I could just have a look at like what a simple, I'm not saying it's bad or anything, but like a simplified spotlight. If I go to my Discord, oh, I don't have the viewer account. Oh, okay, there we go. Look. While I, yeah, if you tell me what, I think if I look through the resources, you should. Okay, so I'm gonna take Ratchet right now. So for people who don't know, who's watching, Ratchet is a really competent graphics programmer. So yeah, I have full confidence that this will make more sense, because he's probably written. Okay, so I'm gonna throw this in. I'm not gonna copy it 100%. I'm just gonna, so it's in one place. Okay, so it's the fragment shader, and then we've got what, range. So I see. So this is the, okay, I'm starting to see this now. Power 4, which is, it looks like this is closer to the maths. Not this filament. No, I'll just bring up my stuff. Now, I won't just copy someone else's code and just say that's mine or anything like that. This is more just like as a learning experience, so I could. That means, Crispy, that how light degrades as it gets further away from the light source. I would argue that I'm barely competent. You undersell yourself there. So what am I doing here? I'm looking at the maths versus the code that we just picked up. So I'm just going to look at this, and this is the. This is this. Okay, so we have a distance -1, which is the saturate. So this is a clamp of 0 to 1, which I'll fix in a second, which I know how to do. So this is the okay. Okay, so you got intensity. Power 4 is just, yeah, x to the power of 4, x tesseract. You can't see. Hopefully you can see that Dimitri, the auto translation is it's working for me, but yeah, Dimitri's I think Russian, and he's got the auto. So if it breaks on you, I apologize. Okay, so let's look epsilon. Okay, look, I gotta keep my eco in check. I gotta start thinking I can't stop thinking I'm him, because I won't learn. Yes, I know what you mean. 100%. I feel the same way, to be honest. Okay, so I've got literally. Okay, guys. I said this was a small stream. Unfortunately, this is the end. I will send you guys my Discord server. Anyone's allowed to join at any skill level. Feel free to join as long as you follow the rules and it. I will share that for you guys. One real quick. So bear with me just a moment. Yes, but I just before you go, I just want to thank you all for again this milestone that I've been, gunning for since about March. So yes, very much appreciated. Getting us getting to 2,000 and above is very much appreciated. Thank you guys for that. It's wonderful. So if you've been subscribed for like a small time and a short time, very much appreciate that. Thank you guys. I will write a yeah RDX 5070 giveaway, 5090 even. So yeah, I very much appreciate you all. If you've just subscribed or you've subscribed for a long time, it's always nice. It's been brilliant. Yeah, thank you for the congrats there, Ratchet. Yeah, I will keep working hard on this. But yes, it's difficult to stream on long on the weekend. So yeah, I will leave you there. Have a good rest of the day, guys, and thank you very much once again. All right then. Bye, guys. See you soon.